So I'm super excited because we have a speaker based in our host city. Alec J. Warren will be presenting Building Understanding Through XR Experiences, Science Museums as Visual Communication Centers. With 15 years of experience in museums and informal education, Alec specializes in creating engaging experiences for diverse public audiences. As the director of the Frost Planetarium at the Philip and Patricia Frost Museum of Science, he leads the strategy, programming, and operations of the 20-meter dome, which has served over 3.5 million guests since opening in 2017. He also founded and leads Frost Science Studios, the museum's immersive media production house that services the Frost Planetarium, museum exhibits, and collaborative media projects. Warren holds a Master of Arts in History, a Master of Education in STEM Education, a National Certificate for STEM Teaching, and is currently pursuing a PhD in Educational Technology. Wow. This sounds like my dream job. So welcome to the stage. And Alina, can you help me with the slides? Okay. Any fun facts about yourself you want to share?
It's awesome to be here today. Thank you all for having me here. How many of you have ever been to a planetarium before? Raise your hand. Oh, I love to see that. I'm in the right place. That's awesome. How about this? How about we start the talk? I want to start with a quick visualization exercise. First, let's go ahead and put the first slide up here. I'm going to go ahead and swap over. I wanted to show you this image, because this is one of my favorite images of us. And you might say, well, what do you mean? Well, this is the cosmic web. This is a rendering from the Max Planck Institute of Astrophysics. And it shows the lattice structure of our entire universe. So somewhere in this image, technically, is all of us, as well as every living person, every animal, our entire planet, our entire solar system. The Milky Way galaxy is in this image. Every piece of data that we've ever collected or observed or thought about is represented in this image somewhere. Not to do too much of a Carl Sagan cosplay, right? Talking about the pale blue dot, right? But now I want you all to stand up. Go ahead and stand up with me. Come on. Yeah, stand up. And I want you to go ahead and just reach up. Reach up for the stars. Yeah, reach up for the cosmos. You can join us online as well. You can stand up, reach, yeah, get that blood flowing a little bit. And I want you to close your eyes. And I want you to imagine that you're in the cosmic web, that it's flowing past you, that you can see the filaments of dark matter and the cosmic dust swirling around you, above you, side to side, behind your head. I want you to picture it in your mind. Visualize it. All right, go ahead and open your eyes. Go ahead and put down your hands. Go ahead and sit back down. So how many of you could actually picture the cosmic web in your brain? How many of you saw something in your head? You just saw the photo, right? Yeah, so you had a good reference. Okay, that's awesome. Yeah, that is what's amazing about human beings, right? We have visualization tools inside of our brain. We can picture the world around us. We can imagine it. But we're not all imagining the same thing, of course, right? It's all dependent on what data we have to reference previously. You know, I provided an image reference, right? But you may have your own biases baked into your brain or your various experiences. They're going to inform what you see in your mind. So it's always helpful to have some kind of visual aid. I mean, that's what you all do, right? You create the visual aids to help people understand data about the world around us. Now, what if there were a visual aid that could help immerse you in that environment, immerse you in the cosmic web, actually make you feel like you're flying through it, show the structures of our universe in 3 dimensions as they as they actually exist, as opposed to a 2D representation of a 3D structure. Well, there is such a place here in Miami where that is possible. It's about as wide as this room. It's actually a little bit wider than this room, and it's taller than this room. It's 4 stories tall, 67.5 feet across, and seats about 250 people at a time. It's the Frost Planetarium that I'm talking about. It's the largest immersive space of its kind in Miami, Florida, and it's one of the 10 largest planetariums in America. And I'm not just up here to brag about that, the fact that I work there, and it's really cool that I do work there. But like, I couldn't have asked for a more amazing opportunity. But there are such places where these tools exist that help people spark their imaginations and it can actually immerse them in data. And planetariums are probably the biggest example of that. But on an individual level, you can do a very similar thing using virtual reality or even augmented reality. You can use AR tools to have somebody hold a data chart in their hand, for example. You could have the cosmic web or really any other 3D environment represented in virtual reality and allow people to explore data in 3 dimensions that way as well. So these extended reality or shared reality tools are extremely helpful for helping to get people thinking about data and experiencing data in a different way. It helps provide an alternative perspective. And there's actually an amazing example of this that actually came out last week. The American Museum of Natural History in New York, their team up at the Hayden Planetarium, just finished production on a new planetarium show called Encounters in the Milky Way, narrated by Pedro Pascal. That fact is not important to the story I'm about to tell, but I just thought you should know that Pedro Pascal is narrating a planetarium show. And during the production of the show, they took a data set from a data scientist who specializes in the Oort cloud, which is this theoretical cloud of objects that sort of forms a shell around the outer solar system. We don't even know if it really exists, but we think it does, and we think that's actually where comets come from. And they put in this data set that this scientist had collected about the Oort cloud, put it into their visualization system that they use to produce the shows. It's called Open Space. It's actually an open source astronomy visualization system. And then they projected it up onto their planetarium dome. And while they were watching the scene that they had rendered out for their dome, they noticed something really strange about the Oort cloud. There were swirls and objects moving in strange ways that they did not expect. They were literally watching the show, and then somebody pointed over to the side and said, "What is that?" And it looked like a hurricane. And what it turned out to be was actually a new discovery about the structure of the Oort cloud itself. We had no idea that the Oort cloud had these complex movements, these complex relationships between objects. And we probably wouldn't have known that unless we put the data into a visualization system and projected it in 3 dimensions around, where people could actually look around the scene and make observations about the environment around them. So a planetarium show helped data scientists make a discovery about the structure of our solar system. That's pretty cool, if you ask me. That's an extreme example of the types of possibilities that can come about when you see your data in a 3-dimensional environment, when you see it in a different way. And that's why science museums, broadly speaking, have adapted and adopted a lot of these XR experiences into their exhibitions, into, of course, planetariums and other giant screen format theaters. That's why they bring it there, because one, it helps researchers understand their data in a different way, and two, it helps bring science to life in a unique way for public audiences. And the fact that it does that is really important because we live in an era of information overload, as we've touched on over the last 2 days, right? There's data all around us. There's data being thrown at us left and right on our phones, on our laptops, in the podcasts that we listen to. We're receiving information constantly. We're being bombarded with information. And most people these days, well, they're losing the ability to discern fact from fiction, reality from untruth, right? That is a major issue in our world today. That trust in the information that you're receiving has been largely eroded over the last several years. And it doesn't seem to be improving. It seems to be getting worse, especially with the advent of generative AI tools, where you can type a message into ChatGPT and it can spit out a falsehood, right? Or images that can be generated in seconds that never happened in reality, right? Voice modification and modulation, deep fakes, where you can have President Obama, for example, say a message that he never said in real life, right? This is a real issue. And across the board, we're finding that trust in public institutions and public sources of information are being eroded. People don't trust the sources of information that they're engaging with on a daily basis. They don't trust newspapers like they used to. They don't trust news outlets. They don't trust their government. They don't trust schools or universities in the same way that they used to. But there's one notable exception to this rule. It's science museums. Science museums, for some reason, and I'll explain the reason in a second, are consistently scored in surveys as the most trusted public institutions in America. Yeah, the American Alliance of Museums conducts annual surveys across the country, across demographics, and across political spectrums, and asks people, what institutions do they trust? Science museums score on par with friends and family in terms of trusted institutions. Statistically speaking, people trust me more than they trust data scientists or actual experts in their field when it comes to astronomy. I am not an astronomer by trade, but I am an educator, and I work at a public institution where we represent science in what people perceive to be a non-biased way. People trust science museums because they perceive us as being unbiased, neutral sources of information. Now, is that true? No. I'm here to tell you that that is a myth about science museums. We do have an agenda, and it's usually in the form of our mission. Our mission at Frost Science, for example, is to bring science to life, to inspire joy and wonder in science and technology through all of its fields and in all of its aspects. And extended reality tools are a way to do that in an engaging way, to make people engage with data, with content, with science directly, right? So not only do we have extended reality tools in our exhibitions and in planetariums, we also have our audience. We have public trust, and we have large quantities of people coming to our facilities on an annual basis. Over 100 million Americans visited a science museum just last year. So we have large audiences, we have their trust, and we have tools that allow us to demonstrate science and data in a really interesting and immersive way. What we don't have is you. We don't have experts necessarily. We don't have data storytellers or science storytellers. We don't have visualization experts who are masters in their craft. That's where the relationship can really be built. We, as science museums, can help provide you with an amazing platform for your data. You could tell stories to 250 people at a time on a 20-meter dome in 8K plus resolution. That's the possibility when you work with a science museum like Frost Science. And in return, we provide you with an audience that is trusting the information that you're putting out there, that trusts that it's reliably accurate, and you're helping us in return by giving us awesome content to work with and accurate science. So it's a power that we have in science museums and in planetariums, but it's also a responsibility. Because the public trusts us almost implicitly, we have to make sure that the information that we are presenting is accurate and engaging. And so that's where that collaborative relationship between visualizers and data scientists and science museums and institutions really comes together. And over the last few years, my institution has really embraced this. 3 years ago, we didn't really have very many visualization platforms. We didn't have a director of the Frost Planetarium, and we didn't have a visualization studio. Now we have all three. We also have immersive exhibits that we've added within the last 2 years to our institution. We have what I would classify as sort of mini planetariums within our exhibits now, where we can feature virtual reality and extended reality experiences that guests can actually walk up to, select an experience, and be guided through a story, or explore the data on their own time and of their own accord. We've formed relationships with partners such as NASA, for example. NASA's Scientific Visualization Studio is now featured in our planetarium lobby through their Earth Information Center. We're the first museum in the country that's not affiliated with a government institution to feature NASA's Earth Information Center in one of our exhibits. And we've also developed programs in partnership with visualizers and visualization experts to get students involved in data visualization and rendering of content in real time. We've been able to use tools such as Google Earth Studio, for example, or Blender, Maya, really any of the tools that we've talked about today, and get high school students creating their own guided tours of, say, their neighborhoods, or explore how sea level rise may affect their neighborhood here in the future. That's a big problem that we have to address here in Miami, by the way, being so close coastally. So over the last couple of years, we've dove headfirst into the world of data visualization and bringing it into our museum so that we can engage guests in more interesting and vital ways, quite frankly. Now, this has been great, but of course there are some obstacles to this. It's not always easy, and you all know this well. I don't have to tell you this. Different platforms require different file types, right? What works in one medium is not necessarily going to work in another medium. The biggest challenge that we face in the planetarium, quite frankly, is whenever we're working with an outside partner who's used to working in a 16:9 box for all of their data, and then suddenly you introduce to them the possibility of creating something in 360 degrees. You literally have to think outside the box. And that's not always the easiest thing to do, nor is it the easiest thing to create content for something outside of the box. The amount of data required and the amount of GPU and rendering power required to create something awesome for a dome is much more than it is for a laptop. So accessibility is always a challenge, of course. Budget and cost is always a challenge. And frankly, there may not always be an opportunity to collaborate with a local science museum, for example. They may not have the same resources as some of the larger institutions. But if there's a story worth telling, and it's within the means of the organization that you're speaking to, then more often than not, that I've found in my experience, science museums will be willing to work with you, because their missions, although worded differently from place to place, are largely the same. We want to educate, we want to inspire, and you all help us do that. And technology tools that we have at our disposal can help us do that in a really cool way, literally outside of the 16:9 box that we're used to working in on a day-to-day basis. So just some tips for implementation. These are more for me, but they're also for you all as well. You know, if you have an experience that you think would be interesting to tell in a dome or in an XR experience, and you want to work with a science museum, then connecting it to their mission in some way is really the way to go about it. It helps you meet them where they are and tell a cool story about your research or about whatever narrative data set that you happen to be working on. And also starting small. Starting small is always a key with this as well. And prototyping and evaluating and scaling on a careful basis. are the keys to finding a successful partnership and relationship with a science museum such as Frost Science. And also prioritizing that interdisciplinary collaboration. There's a lot of interdisciplinary folks in here right now. Some of you are more on the design and art side. Some of you are more on the engineering side. You all have to work together. And we, as both clients and creators and curators, work with all aspects of that process as well. So that collaboration helps us create experiences like this. This is ultimately what I'm aiming for whenever I present anything in the Dome. I want a full audience. I want really amazing content up on our Dome, and I want people to walk away having understood something, right? And so visualization helps us accomplish that. And with that, I want to leave the rest of the time for questions, if anybody has any. But thank you.
This is for you.
Oh, thanks. Oh, I have a lapel mic.
Oh, sure. Sorry. Okay. I'll take this one. There, we got a question in the back, but in the meantime, do you have one online? Nope.
They're ready to go.
What number?
2. Oh my gosh, hi. We went to high school together. Oh my gosh.
How you doing?
Catch up. Yeah.
We actually did, it's mad, so many years. We met 2 years ago in Porto too. Anyway, hi.
Hi, hello.
Thank you so much for this talk. Really exciting to see experiential learning. It's an amazing thing. So curious, so let's say somebody wants to approach you with something, or you have a new build. What tends to be the lead time between ideation towards the final execution of it? And also when you get projects, what's the levels of permits that needs to go through before it crosses over the line?
That's a great question, and it really varies by the project, right? It depends on the scale. For example, if we were to create a planetarium show with a partner, that is a process that takes several years, and in some cases can take hundreds of thousands of dollars of funding, right? So that would go through a fundraising process, a scripting process, before we even get to creating the visuals, right, and creating animations and flows. And those usually involve teams of dozens of people working together, from data scientists who are helping to provide the data, scientists who are providing advice on what should this visualization look like and how should it come together. Those are usually really robust teams to create a full planetarium show. But if we're creating, say, visuals for like a large LED wall display or a small projection theater, those can go much faster. Those can be over the course of maybe a couple of months, and they can be done with a much smaller team of people. It's usually myself along with the visualizer or visualizers, plural, that we happen to be working with. Like Vinny, who's here, is going to be volunteering with us here pretty soon to help us make visualizations for our large LED display that we have in the lobby of our planetarium. So that's an example of like a local connection that we can make with someone based out of the University of Miami. We've also worked with student groups at Miami-Dade College, where they've actually produced a full dome trailer, a 2-minute trailer for our planetarium in Unreal Engine, and also using actual data models to create real lifelike dinosaurs, for example, that they've baked into their Unreal experience. So it varies by the project. It varies by the scale of what you're trying to achieve. I think like any other project that we may work on. It can range from 2 people to 100 plus. Yeah.
Thank you.
Mm-hmm. Yeah, thank you.
Any other questions in the room?
Hey, great talk, thank you. How connected are different planetariums across the nation? Say you produce, put so much resources into one production. Can my local planetarium pick it up and, stand on the shoulders of the giants?
Yeah, that's a great question too. So there are various networks, as well as conferences that the planetariums around the world have, actually. There's an organization called the International Planetarium Society, and they meet every 2 years at locations around the world. They also have a quarterly newsletter that they release as well. There are distribution channels for content, so there are companies wholly dedicated to serving planetariums and giant screen cinemas that distribute content that planetariums and production companies are producing for domes. So that there's really, it is a niche market, but there is a large network of institutions and organizations that work together not only to create content, but to distribute it to other planetariums.
Cool. Quick follow-up then. What's the proportion? How many of them are like in-house productions that you have, and how many of them are coming from these?
Yeah, it's going to vary by the organization. There are some planetariums where they only do live, real-time visualization using their planetarium system, whatever it may be. There are some that operate really like a movie theater, where all of the content that they're getting is from outside sources and they're just running it like movies. Our planetarium is actually a mix of both. We have pre-rendered, what we call canned shows that are going to be the same experience every single time. And then we have live productions that we make where we're telling a story, where we're using real data and we're using real information, we're visualizing it in the dome, and we're couching it in a narrative to tell and to explain something. Yeah, no problem.
Okay, well, any other questions? All right, well, okay.
Follow up to what you just said. I'm very fascinated with this idea of real life or real-time data being turned into a narrative. I've never seen a show in a planetarium like that. I know it's not the same as experiencing it, but could you give an example of what kind of data would one of those shows capture and what it looks like?
Yeah, that is a great question. So many planetariums have digital systems that are proprietary to planetariums, and they're essentially astronomy visualization platforms, like sandboxes that you might see online, like Open Space is an example of one. I'm trying to think of a name of like a really, like it's almost like a video game, right? Where you can pilot through space in real time. You can land on the surface of Mars. You can go see the sun up in close detail, right? You can go to the edge of the Milky Way galaxy and see data sets provided by Gaia and other recent missions and surveys. You can see sky surveys as well. So they're essentially astronomy simulators that are updated regularly with content from official sources, right? And this visualization platform allows us to sandbox and fly through space in real time. So if you wanted to tell a story about Saturn's rings, for example, and the moons of that planet, you can go to it in real time, show it as it would appear at that time of day, and it'll be in its real position. You can even see eclipses occur between moons and planets as well, outside of our Earth-Moon system. And you can actually talk about it. You can tell stories as simple as just narrating what's happening, all the way to a more complex narrative about, hey, are there bugs living on Europa, right? So if you wanted to get creative, you could do that too. Are there bugs on Europa? Most likely not. I mean, there may be crabs or like crab-like beings beneath the surface of the ice. There's probably 2 to 3 times as much water on the moon of Europa beneath the surface ice as there is here on planet Earth. So there's a likelihood that maybe there are living things in that ocean beneath its surface. And maybe there are crab-like things or bacteria or other things like that. So we don't know. That's the real answer. We did send the Europa Clipper mission to Europa. It'll get there in the year 2030. It's going to be doing high-resolution scans of the surface as well as radar scans beneath the surface. So we'll have a lot more data to sift through in about 5 years or so. And maybe we can answer that question. But for now, we don't know. It's a good question.
You learn something new every day, but I hope we've learned many things today. As we're transitioning slides to the closing remarks ones, while we have a speaker from Miami here, how many people have gone to the beach yet? No?
A couple of people.
Okay.
All right.
Anyone had a Cuban coffee? Okay. Any other recs for not to like reduce your city into these two things? But,
You know, before, if you're coming from out of town, before you leave, definitely check out the downtown area. That's where the Frost Science Museum is. If any of you want to go to the museum, just reach out to me. I can get you tickets while you're here. Yeah.
Oh, I missed it.
Yeah, so just you can send me an email or message me. Yeah. So you're more than welcome to check us out if you're still in town. Just let me know. I'll email them to you. No big deal. Yeah. So there are other museums downtown as well. The Perez Art Museum is right next to us. Biscayne Bay is right there as well. So yeah, couldn't recommend it more. Maybe, I don't know.
I did get a question from our online crowd for
Okay.
you. Thank you so very much for this talk. This is from Desiree. You mentioned early on that planetariums and science museums need people like us data visualizers. How can we better position ourselves for these types of roles? If I do mostly Tableau and Figma for business reporting right now, what skills do I need to beef up?
Oh, that's a really good question. You know, a lot of the skills that you probably have currently are absolutely applicable to science museums as well. Whether that's on the more of the educator or curatorial side, or even just on the business and administrative side as well, like our graphic design team, our marketing team. I mean, they do a lot of what you all do as well, right? In terms of using tools like Asana and Tableau to organize their projects, organize information. Our finance team uses data visualization to visualize the hours and usage. So a lot of those business applications apply to our organization just like it could really apply to most others. So yeah, I hope that answers that question.